Hi there, this is Mr. Delovit, your physics teacher. Today we continue looking at mathematics in ordinary level physics, part 5. So we're talking particularly on trigonometry. As I said in the previous videos, it will be difficult for you to have an A or to have a pass mark in physics without understanding the mathematics that is involved. Maths is a language for physicists. You need to understand it because there is no equation in physics that will not involve mathematics. So today we'll be focusing on trigonometry. I know some of you have come across optics and you've seen things like the refractive index is sine theta 1 on sine theta 2, or you see something like I on sine r, where, oh, sorry, that was writing. So you have seen something like refracting equals to the sine theta 1 on sine theta 2. You've seen, or you have sine I on divided by sine r. Things like this, where I is the angle of incidence and r is the angle of what? Refraction. Now, you are expected to know how to evaluate sine theta 1. You're supposed to know how to evaluate sine theta 2. You're supposed to know how to evaluate sine I, and you're supposed to know how to evaluate sine r. There are also questions that you've seen on forces. They ask you to resolve two forces and calculate their resultant. Like you say, okay, r is equal to f cos theta plus f sine theta, something like this. And at this level, you're expected to know how to evaluate these form of equations or these concepts in physics. And also, you're also expected to know how to look for theta. For example, if they give you an equation like n1 sine I equals to n2 sine r, you're expected to know how to look for what? I. So I is equal to n2 sine r, sorry, I is equal to the sine inverse of n2 sine r on n1. So these are different concepts you're going to be seeing in physics. How to look for the sine inverse of different values, how to look for the sine of angles, and so on, cos and tan. If you don't know how to use the calculator to do these things, it will be difficult to have a pass mark in optics, to have a good mark in resolving forces under mechanics. So you need to know how to master how to go about this concept in mathematics, and it's going to help you a great deal if you know how to do it. Okay, if you're ready, let's march on. Now, before going into telling you how to go about this thing, the first is you have a background knowledge on trigonometry. So trigonometry will focus on the right angle triangle, and we know a right angle triangle is a triangle that one of the angle is 90 degrees, and we have the other angles either 30 and 60. So by the sum of the angle of the triangle must be 180 degrees. As I said, a right angle triangle is an angle triangle in which one of the angles is 90, and the sum of all the angles, the three angles that make up this triangle, must sum up to give you 180 degrees. Now, in this triangle, as we see, now they can ask you, you have what this side is called the hypotenuse. Now, we have another two sides. We have the opposite and the adjacent. we have the opposite and the adjacent. The opposite side and the adjacent side would depend on the angle you're talking about. It will depend on the angle you're talking about. For instance, if our concern is this angle, 30 degrees, what will be my opposite? This will be my opposite. The opposite will be the angle that is directly opposite the 30 and is not touching the 30. Now this will be my adjacent. Adjacent will be the angle that is touching the angle. It will be the side that is touching the angle 30 degrees. And the hypotenuse does not change. It's always the angle, the side that is opposite the angle 90 degrees. The side that is opposite the angle 90 degrees is what we call the hypotenuse. Now, if I'm talking about 60, if I'm talking about 60, now what will be the opposite? Now, this will be the opposite. And this will be the adjacent. So see, the adjacent and the opposite of the different angles depends on where the angle is situated. Now let's look for these things, and then, for example, let's look for these things and see how we can able to solve, like get the different angles. Now, normally in maths, they always have these let me normalize try invisible. Okay, have this one that the hypotenuse is 2, has a value 2. This I have 1, and this side is root 3. So you have the hypotenuse 2, this side is 1, and this side is 2, root 3, sorry. Now, doing this, and how did they get about this? They got about this by using the Pythagoras theorem. I know you know Pythagoras. I said the hypotenuse is equal to the square root of the opposite side squared plus the adjacent side all squared. That's what you call the Pythagoras theorem. So now, if, for example, for you to look for this man 2, if they say the opposite side of the angle, we have 1 all squared plus root 3 all squared. So you have the square root of 1 plus 3, and you see that the hypotenuse will be equal to the square root of 4, which is equal to 2. And that's why you see this side is 2. And this Pythagoras theorem is very important, because when you will be doing forces and resolving of forces, you realize that this hypotenuse will be related to the resultant force. We'll be calling it the resultant force. So you have to take note of that. So you see, we'll put diagrams like this. Now, and I'll draw a line like this. And this line will be our R, which is the resultant force. And now, if you do all this side is also like this. This side is the same as this. So that's why you see this triangle is the same as this one. So we can have different angles. It is my theta, then there will be the opposite side, and this might be what? The adjacent side. You can see have the angle, this same diagram like this. And the resultant is down like this. So you see that this angle, this side, the one is same as this one. And you can see have an angle like this. It will become the opposite, and this will become the adjacent. So that's how you'll be seeing in under resultant forces. So I know that this resultant force, if this side will be the square root of the opposite squared plus the adjacent all squared. So that's what you'll be seeing under resultant forces. So Pythagoras theorem is very important when we're doing resolving of forces. So you need to know what Pythagoras theorem is all about. And you know that arrow result will be is the longest side, is the side that is opposite the angle 90. The side that is open the angle 90 is the hypotenuse, and in physics we'll be calling it the resultant forces when we are talking about resolution of forces. That side that is resultant will be the side that is opposite the angle 90. Now, as we're talking now, there are many cases that we can use in how to understand how can I get the value of sine 30, sine 60, sine 90 without even using a calculator. Now, okay, let's look at that. Now, look for cases in the case that now if you look at this case, now this is our triangle, as we said before. This is 90, this is 30, and this is 60. So this is 1, this 2, and this is 3. Now, look for sine. What we know, look for sine 30. So, sine 30, it will be the opposite over hypotenuse. And now, what's the opposite side? This is the opposite side. And where's the hypotenuse? So what's the value there? We have 1 and 2. Cos 30 is adjacent over hypotenuse. What's the adjacent of sine 30? This. So you have root 3. What's the hypotenuse? 2. You have 2. Now tan 30 is opposite over adjacent. What's the opposite? Opposite is 1. Adjacent is what? Root 3. If you take your calculator and punch, you have the same values on your calculator. Now, let's look at the other angle, 60. What's sine 60? So sine 60 will be equal to opposite over hypotenuse. So what's my opposite? You see this is your opposite. Now, and what is happening is, so we root 3 and what? 1, 2. Now if you look at the next, cos 60, all it becomes will be adjacent over hypotenuse, which should be equal to, what's the adjacent of 60? The adjacent is 1, hypotenuse 2, so it will be 1 or 2. Now tan 60 will be equal to, what's the opposite? Will be opposite over adjacent, which is equal to, opposite now was root 3, adjacent was 1, so you equal to root 3. So that's how you can, if you punch these values, you see the same thing on the calculator. So if you can master these values, then it's good for you. For instance, you have a table. Let's have it like a table like this. Okay, let's say that these are angles. There's 0, 30, 60, 90, 180. Now if you have this, the sine, cosine, and tangent. So what is the sine of 0? Is 0. Sine of 30 is half. It's 1 or 2. The sine on 60 is root 3 on 2. Sine 90 is sine 90 is 1, and sine 180 is 0. Now we change the column. What is cos 0? 1. Cos 30, you have root 3 on 2. Cos 60 is half. Cos 90 is 0. Cos 180 is minus 1. Now you have next. Now tan 0 is 0. Tan 30, what do we have? We had 1 on root 3. Tan 60 is root 3. Tan 90 is infinity. And tan 180 is 0. So now, if you look at all this, you can master this diagram. Then, if they ask you, find refractive index. Find refractive index, which is n is equal to sine 30 on sine 60. What will be your answer? You just come, what's my sine 30? It's half divided by sine 60, root 3 on 2. And you say your answer will be 1 on root 3. I'll give you your answer. As simple as that. Now, or you can go to your calculator, you punch sine. I'm going to show you how to use your calculator. Now, if they ask you, okay, find the resultant force, that rho is equal to 20 cos 30 plus 10 sine 90. You have a diagram like resultant force like this. So what would be your answer? It will be 20 times root 3 on 2 plus 10 times what? 1. So you see that your answer will be 10 root 3 plus 10 times which was 10. So your answer, this will be your answer in set form. But if you can use a calculator to make the answer into decimal, it's no problem. But that's the answer. So I just want to know this, how you can do the calculation without using a calculator. Now, in your exams, you must be asking about, they'll ask you about 45 degrees, 30 degrees, 0 degrees, 60 degrees, 180 degrees. And these are the angles that you must know their value. You need to know their values offhand. You need to know them into your head without even using a calculator. So if they have there, you don't need to wasting time and like punch the calculator. But now, if you need a calculator, now using a calculator, and you need to do like this one. Okay, they said n is equal to sine 30 on sine 60. Now you also use calculator. So how do you get this value? You go on your calculator, scientific, you press sine, open the bracket, press 30, close the bracket, press division sign, and then you press sine, press 60, close the bracket, and then you press equals to, and then you have your answer. You have your answer on the screen. You have your answer on the screen. That's it. Now, some people have some different calculators. Calculator does not have, it's not a scientific one. That's like does not have the order. So in that case, for you to do that, you have to take now the other calculators, which okay, you have to press 30, press sine, and you have a value. You equal to a value. Copy and keep and write down. Then you press again 60, After you press sine and you have the value, you copy and write down. Then now you come and take the value of 30 of sine 30, and then you divide, you press division of the value of what, 60 degrees, and then you have that. Right, like if we can look at this calculator, yeah, something like that. I don't have a good calculator for you to show how it's working, so but that's how you do it example. But in the next video, if you need me to show you how on the calculator itself, I'm going to download the calculator and then show you how it works right hand. You understand? Okay, good. Now, so that's how you use it. That's how you use the calculators in doing that. So if yeah, that's how you use calculators to solve that problem. Now, next thing they can ask you also is that, okay, now if you have and refractive index is sine theta is sine 30 is equal to n2 sine r. Now they're asking you to look for r, right? And in the n1 is 1, n2 is 1.5, for example. Now for you to look for this r, you have to make sine r the subject of the formula. So you have to make I sine 30 is equal to n2 sine r. So this one comes this way. We have n1 sine 30 by n2 equal to sine r. Now in this case, now what do you have? You have to make this r the subject. You have to take sine inverse on both sides. It will be sine inverse of n1 sine 30 over n2 equals to sine inverse of sine r. So sine inverse of n1 sine 30 on n2 will now be equal to r, because sine inverse times sine r is r. That's how you do it. Now in physics, normally you don't have to use a calculator. You don't want to use a calculator. It's very simple. You just go here, you just have, okay, sine inverse will be equal to 1 times half over 1.5 equals to r. So your sine inverse will be be 1 on 3. Sine inverse of 1 on 3 equals what? R. Now you cannot do this one manually. You need to always use a calculator to do the sine inverse of 1 on 3, right? So you have to, what do? You have to go to a calculator, very scientific. You press second function, press sine. After you press sine, open the bracket. This, if you press sine, sine inverse appears. Open your bracket, you press 1 divided by 3, and then press equals to, and you have your answer. As simple as that. So that's how you get the answer. In the other calculator, it's very long. You have to press second function, press sine inverse, and then open the bracket. It's press sine. You have to press, sorry, you have to press second function. Press. You have to do first. Sorry, for the other calculator, you have to do 1 divided by 3. So your first other calculator, you have to press 1, divide it, press division, then press 3, get the answer. Now when the answer is on the screen, press second function, then press sine, and you have a correct answer. So that's how you do it for the other calculators to get that. So this was very pertinent, especially when you're working with different values. For example, um, when you're working, for example, they can give example like it's example for you to do like, okay, evaluate f equals to 2 cos 60. What will be your answer? It can ask you to evaluate um theta is equal to sine inverse of 1 and 2. What is your answer? It can ask you to evaluate um um cos theta is equal to 4 on 5. Find theta, right? So how are you going to do that? So just pause the video and see how you can able to accomplish that. But if you can, what you just need to do is try to hurry up with that. It's what you do. All I'll do is that solution f will be equal to what? 2 cos 60. I'll go to my calculator and I'll press 2 times, press cos, and then I'll press up my bracket, I press 60 and close the bracket. I'll have my answer. That's what you do. But if you want to do it off without calculator, you just have to do 2 times half, which will give you what? 1. So your answer will be 1 Newton. Now if you have 10 theta equals the sine inverse of half, you see that you have to go and press sine inverse on your calculator and then press 1 divided by 2 into bracket and then press equals to. You have your answer. But if you want to do by no calculator, you know this answer is supposed to be what? 30 degrees. As simple as that. Now in this other case, you have cos theta is equal to 4 and 5. How do you do it? For you to get this theta, you have to take cos inverse on both sides. So it will be cos inverse of cos theta equal to cos inverse on 4 onward on 5. And if you do that, cos inverse times cos theta will give you theta equals to the cos inverse on 4 on 5. You're supposed to have something like this. And when you have something like that, you can evaluate using the calculator to have the answer. So that's how simple it is. So you need to master these things, and the main thing is practice. So if you want more support, get your description below for me to can support you to help you to have the A's, and you need to solve as many problems as possible under optics, under resolution of forces, under resolution of forces, so that it can also help you to and under work done, so you can know how to evaluate these values, so that you can and then know how to use the calculator in calculating sine 30, sine inverse of a number. Yes, but if you're not, you cannot don't want to use a calculator, you can use the method of just the triangle to know the various values of sine 30, sine 60, sine 0, sine 90, and sine 45. If you have not done that for sine 45, but if you need it, I can help you show you how to go about it. Thank you for watching and have a blessed day.